So, warm up today, same thing as warm up yesterday, essentially. Third one, we're going to try to start solving equations with this. And today's topic is solving equations by graphing. So anything by graphing is a pretty easy little lesson. You just do what you always do with graphing. You remember what you did in the last unit whenever you had to do anything compared to by graphing? If there was a line, you had to set it equal to 0 and graph it, right? If it was an inequality, you got to compare it to 0 and graph it. With quadratics, we're going to get it compared to 0 and graph it. So it's going to be the same thing with every function we do all year long. Here we go on this. If you go ahead and crunch the numbers, negative b over 2a, you get that the vertex is at the x coordinate of 4. So to figure out where the y coordinate of this thing should be, you need to go ahead and take 4 and plug it back into the original equation. And I'm going to do it with my calculator right now to save some time today. So it says negative x squared, x is 4, plus 8 times 4 minus 10, and I'm getting 6. So when I plug 4 into this, I get 6. So 1, 2, 3, 4, 5, 6. Right there will be my vertex. And after that, all I got to do is kind of draw if it's up or down. Now today, if you're doing this by hand, you'd want to draw very carefully because you're trying to see where it crosses the axis. So you want to draw a very close picture or use your calculator. But for us, roughly, it's got a negative in front, so it opens down. So it looks something like that right there. And that's a good rough sketch of this graph. Domain and range. Domain will always be all real numbers, so everything from negative infinity to infinity. And the range, all the y's are allowed. It does go down to negative infinity and creeps all the way up to right there at 6. And that's as high as it goes. So negative infinity up to 6, but it does get to that height, so we put a bracket on it, and we're good. Make perfect sense? Same thing we did yesterday. Yeah, nothing too tricky today. And one more time for good measure. Number 2, we have x squared. And then minus x minus 20. So this is number 2 right here. And you start off with what you know. I know that x is negative b over 2a. That's where the vertex will be. B is negative 1. So negative 1 would be positive 1. And on the bottom, 2 times 1 is, well, unfortunately, it's 2. So this thing has a vertex at a half. So it's a fraction, so we're going to have to go down the fraction rabbit hole. Nonetheless, I know I will have an axis of symmetry right there at x equals 1/2. And the vertex will be on this axis as well. The question is where, so I'm going to carefully plug 1/2 into this thing and see what I get. And I get a very weird fraction. Turns out to be negative 81/4 if you turn it back into a fraction. And what is that as a decimal? That's about, negative 20. So way down here, past negative 20, way, way, way down here. This thing is going to have a value about negative 20, right, about a half. And this thing's going to open up, right? Pause in front. So shoots up like this. And that's a pretty good rough sketch of this thing. Domain, again, always for this unit, negative infinity to infinity. All numbers can be plugged into a quadratic. And the range is from this bottom number, which was negative 81/4, and it goes up forever to infinity, and we are good on that. So that's about it for graphing things with the vertex and by hand and things like that. Probably in practice, as you get older, you won't actually go do x equals negative b over 2a. You'll just graph the thing with your calculator and see what it looks like from there. But it's always good to have a very deep understanding of where these things come from. All right, now number 3, we're just trying to solve an equation. Don't have to do graphing if you don't want. You remember any skills from Algebra 1 or from previous courses? Maybe we could use those. Anybody got any ideas how to solve this thing? Set equals 0, you could graph it, right? Okay, we could do that. Anybody remember factoring? I was told you were taught factoring very well. Is that correct? Okay, can anybody factor that for me? Can you think of 2 numbers that multiply to be negative 20 and add to be the middle term of negative 1? That's exactly right. So if you can factor things, that's even faster, because the whole reason we're obsessed with factoring is instead of looking at a complicated thing when it's 0, you can look at when the factors themselves are 0. So if I have an equation that says x minus 5 equals 0, that's very easy to solve. What would this solution be? X is 5, right? And over here, if this factor was equal to 0, x plus 4, then that would mean x is negative 4. So I found 2 answers to this without having to go to a graph whatsoever. And that's eventually what we're going to lead up to. Today, we're not going to do that. We're just going to solve by graphing, but I guaranteed you, if you graph this thing, it would look something like this, and it would go through -4 and 5. And you would see that's what a 0 is, right? When you graph something, you're looking for it crosses the x-axis, correct? So -4 and 5 is where that would occur at. It would open up just like this. So it would look roughly like that, cross at -4 and 5. And you're welcome to go do it graphically if you need to. Factoring is better, but that's for another day. We're not going to get into factoring quite yet today. All right, let's do some LGs and get ourselves to work. Pretty straightforward lesson. Solving things by graphing. I'll probably throw another 20 functions at you throughout the year, but as I do every single time, I said seems to be a theme, we're going to solve these all by graphing throughout this curriculum. I'm sure the strategy will always be the same. Get it one side equal to 0, graph it, and see where it crosses the axis over and over and over. All right, you got your homework due today. You got a new one, of course. New topic, new homework. It's not due until Monday, but that is just one day, okay? So I do want you to get this done over the weekend because it's pretty straightforward because you're doing it by graphing. And you don't need a whole weekend and a work day to do things by graphing. So it is due on Monday. So you have one day to get this done, one school day, and you'll be fine on that. All right, notes. Here we go. This is section 3.2. Solving a quadratic equations by graphing. As always, if I say solve something by graphing, that's the worst method to solve something. This is what you do if you get in a jam and you don't have any algebraic ways to do things. Or if you just lose your mind and forget how to do everything, I guess you could fall back on this. All right, first things first, we should probably define what we've been doing so far. This right here, let's write that down. It's called the standard form, just so you know what you're talking about. Book might say, write the standard form of a quadratic. And like, what are you talking about? It's just having things in order, essentially, the standard form. You have your x squareds first, and then your powers go down. Then there's x to the first, or just x's, and there's no x's. Per usual, we'll have a represent the number in front of the x squared, and b represent the number in front of the x, and c be the constant term, just like last lesson. But this is the standard form of it. And from now on, for any quadratics or cubics or 4th degrees or 5th degrees or 70th degrees that we solve, your strategy will always be to set it equal to 0. Graphing or not, you're always going to want to set things equal to 0. So solving this by graphing is actually pretty natural because you have to solve it by setting it equal to 0 anyway. So set things equal to 0. That's called your standard form. A can't be 0 because if A was 0, there wouldn't be a quadratic. It'd just be a line, and we'd be back to previous sections, which are boring. So just know this is called standard form. Nothing too exciting. Ax squared. And later on, we'll do the quadratic formula. And when we do, A and B and C will have the exact same meanings in this thing. All right, so let's solve them by graphing. Let's try it. There's two ways to do it. You can do it by hand, or you can do it with your calculator. I'm going to show you how to do it by hand. And then we'll probably just cheat and do things with our calculator later on. So write down the example. 10 minus x squared equals 4x plus 14. First thing you have to do is you have to get this in the correct format. So you need it in standard form. You need it to look like this right here. So it doesn't really matter what you do. I like my x squared is positive myself. That's my personal thing. So I'm going to add this over. I'm going to subtract the 10 over. So if I move everything on the left to the other side, that's really all you got to do. Get one side equal to 0. It doesn't matter which one. If you add the x squared over, then it's a positive x squared over here. You still have this 4x hanging out. That wasn't doing anything. And to move the 10 over, you'd have to subtract 10 from both sides. And 14 minus 10 is 4. So this is in standard form right here. Everything's in order. I got my x squareds, I got my linears, and I got my constants on the end. And to solve it by graphing, well, let's go the long way. Let's actually graph this by hand. We're going to start off with the same skills we did in the last section. Let's find the vertex, let's graph the thing, and let's kind of see where it might cross the axis, because that's what I'm after. I'm looking for when it's 0. I'm looking for it crosses the axis. In this particular problem, b is 4. So I got -4 on top. On the bottom, I have 2 times a. A was 1, and 2 times 1 is 2. And -4 divided by 2 is -2. So I'm going to draw this graph very carefully here because I'm trying to solve by graphing. So I want to be very specific. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. Let's see if this gets the job done. So at -2, like before, we know our vertex and our axis of symmetry will be right there. To figure out where the vertex will be, we'll plug the x-coordinate into the original equation. So this is the thing that I'm trying to graph right here. This is what I want to see is equal to 0. So I'll plug -2 into this. And if you do, what do you get? Oh, that's nice. You get 0. So this vertex is at -2, 0. And by looking at this thing, since there's a 1 in front, it's positive, it's going to open up. So it kind of does something like this and something like this. I don't need to be too careful because what am I looking for on this particular problem? I'm looking for where it crosses the x-axis, right? And it's very clear where it crosses the x-axis. It was the vertex, right? So the answer is whatever the x value is here, which was -2 apparently. So apparently -2 solves this problem. So the answer to this is x equals -2. It's a coincidence that where the vertex was and the axis of symmetry was where it hit the axis. Usually that doesn't happen, but this time it did. And to look ahead, had you tried to solve this without graphing, you could have factored this into 2 numbers, x plus 2 and another x plus 2. And if you think about what makes those 0, what makes this 0 is, guess what? -2. So either way you do it, you get -2. You don't have to factor yet, but you might want to start doing that because that's the primary method I'm going to force you to do as we go on. So there's our answer. Let's try this one out. So step 1, is it in standard form? No. So I would suggest the first thing you do is move the stuff on the right over. Get it equal to 0. So x squared on the left. You had 7x, but you're going to move that 31x over and make it negative. So 7 minus 31 x's on the left will be -24 x's. And then you'll also want to move that 144 to the other side, add it over. So plus 144, and that equals 0. So now I got in standard form. And we'll do it by hand one more time, and we'll start being lazy and using our calculator. Fair? Okay, so first things first, where's the vertex? I don't know. Let's go do the thing. X equals -b over 2a. That's what I'm after.
Excuse me for the interruption. We're going to start taking the group photos at this time. We will begin with FCLA. Just a second. Sorry about that. All right. Students, you need to wear a mask out to the football field, the visitor side bleachers, and get in place for the photo. Masks will be removed briefly for the photo when the photographer is ready. And once again, we are starting with FBLA at this time. Thank you.
Jeez, that was going to make us walk all the way out there.
Oh, they're giving us a softball again. Huh. So you do the work, and you get that the vertex, -b over 2a, is at 12. So at 12, you plug in the number, and it turned out to be 0 again. So that's crazy. It's another one where it's 0. And again, it opens upwards. And you can clearly see where it crosses the axis. It crosses it right there at positive 12. So my answer to this particular equation is x equals 12. So it all worked out. And you're basically just keep doing the same thing over and over and over again. Now, there might be 2 real solutions. There might be 1. I don't know. Let's go ahead and try another problem. Let's be lazy on this one. Let's go ahead and let's write down the example 2. Write down example 2. We're not going to write down all the words, but just so you can come back to it. Word problems like this are going to show up on your online homework, so we want to be able to set them up. And here we go. Use a quadratic equation to find two real numbers with a sum of 24 and a product of 143. So you don't know what the two numbers are. So let's name them two letters. What do you want them? How about X and Y? Probably makes sense. Let's see. Their sum is 24. What's the word sum mean, guys? That's right. So one equation they have is the sum of these two numbers, X plus Y equals 24. And then they tell us that their product, which means multiply, has got to be 143. Now, if you go back to some old skills that we used to do, this looks like a system of equations. If this one you solve for y, and you move the x over, so now it's a negative x plus 24, and you substitute it in the other equation, look what's going to happen. You're going to have x times y, which is negative x plus 24, equals 143. And if you distribute that out and move everything to one side, you get a quadratic equation like this. So we can solve this thing and figure out what it is. Let's do it with our calculators because I'm getting lazy. So calculators out. And well, that sucks. We gotta fix that soon. Okay, that's not. You're gonna need these things sometime. If you go to your calculator and go to y equals, what the heck is this? And you plot the graph that we're actually doing. It says negative x squared plus 24x, and then minus 143. With big numbers floating around like 143s and stuff like that, you might not be able to see it in your normal window. Let's see if we can. I don't know. Oh, I kind of see something over here. There's a curvy part. So I assume it's going up, and it's going to have a max over here and go down. So I need to look farther to the right for sure. So I'm going to make my x max even bigger. Maybe I'll make it 20. Let's see if that does the job. There it is. And you see that it crosses at 2 spots, which is what we're after. So like anything, we're going to go find where those are. So you do second calc. That's a 0 we're looking for. When the equation equals 0, you need to go somewhere to the left of the first one. My cursor is somewhere to the left. Check. Somewhere to the right. Guess doesn't matter. One of the answers is 11. So write that down. X equals 11. That's an answer. Similarly, you try to find the other one. Second calc. 0. I need to go to the left of that one. I'm definitely to the left of it. Enter. Right of it. Enter. And you get 13. So your answers are 11 and 13. So the two numbers are 11 and 13. We solved it by graphing. You can see the graph. That would have been very hard to figure out by hand. The vertex would be over here. It'd be hard to figure out exactly where it crosses the axis, which is why you kind of want to get a little lazy and let your calculator do the bulk of the work. So the answer to this one would be 11 and 13. Does it work out? Does their sum equal 24? Yeah. 11 plus 13 is 24. And 11 times 13 is, guess what? 143. So everything's good there. I don't know. Let's try this out. Let's try another one like this. Here we go. You try it out. How would you set this one up? Use a quadratic equation to find two real numbers with a sum of negative 43. So what would change on the board up here? It's the exact same problem. Exact same problem. What would change up here? There's two numbers, right? So this one, the sum would be negative 43. And they say the product would be 306. So you set that up in a very similar way. Again, you might want to use some substitution on this thing. You got two equations and two unknowns. You don't want that. If you solve for y in the first one and substitute that in to the second one, then you have an equation with just x's. And you can distribute this junk out and see what it turns into. It's going to be negative x squared minus 43x. And if you move the 360 to the side, which you have to because you have to get in standard form, it would look like this. And hopefully when we graph this thing, we'll see two numbers where it crosses the axis, and we'll just write them down and be done. So this one's negative x squared minus 43x. And then minus 306. Oh, there's one of the numbers right there. Now you can imagine it's going down and doing a whole big thing and probably coming back up somewhere else. It looks like it's probably coming up back up off screen maybe. So maybe I need to go farther to the right to see the other one. So I'm going to adjust my window again. Maybe I'll go out to 20 again. Seemed like that was a good window last time it worked. Hit graph when you're done. It's coming down. Or it could be going the other way, actually, now I think about it. It could be going up over here, couldn't it? And being like this. So maybe I need to go farther to the left. I don't know. I'm going to keep playing with things until I find it. So I'm going to go farther to the left and the right. I'm going to have the left go to -30 and the right go to +30. And let's see if that takes care of it. Well, there's one of the lines. Man, I don't see the other one at all. Where's the other one? You know it's somewhere. I'm going to go really crazy. I'm going to change my Y's too. I'm going to look really high and really low. I'm going to try to get this shape figured out. I'm going to go -1,000 up to 1,000. I'm just going to play with it until I see what I want to see. Ah, there we go. Okay, that looks more like a quadratic right there. It does cross right here, but it crosses somewhere even farther over than that. So I need to go farther over to the left on the x's. I'm going to go -50. I'm going to go crazy on this thing. So, man, I really had to play with my window to find it, but there it is. And this is why you don't want to probably do this one by hand, because, my gosh, to have all these kind of numbers involved in the scale would be terrible, but that's why we have our calculators. So let's go find them. Second count, 0. I'll do this one since I'm already close to it. One of the answers will be -9. And going over to the other one, -34. Thanks for following along. Appreciate that. I believe that. It sounds plausible to me. It is, in fact, -34. So write down the two answers, -34 and -9. Good job on that. And that's all you got to do for these kind of things. So here's another example. We won't go through it, but it's already set equal to 0, correct? Well, that's nice. You just go graph it. You'd see something like this show up on your screen, and you would try to find where it crosses the x-axis. Now, it might cross right here and right there. I want you to read the directions here. This is a different kind of problem. If the exact roots just means zeros, just means where it crosses the axis, cannot be found. In fact, if you look right here, do you know exactly where that crosses the axis? It's hard to tell, isn't it? Very hard to tell. They want you to state consecutive integers between which the roots are located. And all that is fancy talk for what two numbers is it between that are pretty. This one is between -2 and -1. Would you agree? So if they ask you a question about consecutive integers, you just got to find what two numbers it's between. So it's between -2 and -1. This one over here, the answer would be between 4 and 5. It again crosses some weird spot. I don't know where it is. But since they say consecutive integers, just tell me which ones it's between 4 and 5. And that's all I got to say about that. Just know when they say consecutive integers, you're just finding the two numbers it's between and writing down what they are. And that's about it. So we can do it for this one. Use a graph to find all the solutions to this. State all the pairs of consecutive integers for which the roots are located. Let's just do it. So if you go to y equals, clear it out, and you go graph your thing.
Excuse me for the interruption. It's time for band and choir members. Band and all choir members, please go to the football field at this time where it's been designated to take your picture.
So if you graph this thing, it looks kind of like a quadratic. Yeah, use your imagination. I reset my window. It's a normal window, but it does go down farther. I don't really care about that. I just care where it crosses right here and right there. So I'll do my second count, 0. I'll go take care of the one on the left first. Come on, graph. Get over there. There it is. Somewhere to the left. That's barely to the left, but it counts. Somewhere to the right. We're good. And your answer is -9.52, but since they want consecutive integers, what number is -9.52 between? It's between -10 and -9. So my answer on this one would be between -10 and -9. And similar for the other one. You go find that 0. Go somewhere to the left of it. Coming back up. Boop, 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 boop. There it is, somewhere to the left. Somewhere to the right. And that one's 0.52. So your answer for that one, which two numbers is between 0 and 1. So that's all there is to those kind of problems right there too. And they might give you some applications too, where you have like a kicker kicking a football. This very much looks like something thrown in the air, because it is. The equations to actually model something thrown in the air is a quadratic function that goes up, slows down, comes back down to the ground. We've all thrown something in the air before. But if it's given by this equation right here, you could still analyze it. It's got T's and H's. H stands for the height, and T stands for time. Nonetheless, you can still graph it. You can't graph T's, but you can graph X's. So if this particular problem came up, I would graph it, but we wouldn't be writing T's, I'd be writing X's. I would just be remembering when I graph it that the X-axis stands for time. And the initial height, they say H naught, this H with a little 0 under it, is the initial height. The ball is 1.5 meters above the ground. So the starting height must be 1.5. So setting up this problem right here. Zoom in is probably going to be not an appropriate window for a real application like this. I'm sure it goes very, very high. Oh, yeah, look at that. It goes much higher than this. So I'm going to go a lot higher with my max. How about up to 200? I don't know. I'm just kind of guessing. We'll see if that's enough to see the hump. Oh, yeah, plenty of room right there. So you see it looks just like something thrown in the air. And if they ask you, what's the question asking you? If the ball is 1.5 meters above the ground when the puncher's foot hits the ball, how long will it take for the ball to hit the ground? Now, remember what you're graphing. This is a graph of height, right? So if you are not above the ground, how high off the ground are you? 0. So you're trying to find where it hits the axis again, which is the whole thing you're doing over and over again. So right over here, here's where it's launched. It goes up in the air, comes back down, and hits the ground right there. You can do a second calc. You can find that 0. I care about where it hits the ground over here, so I go somewhere to the left of it. I go somewhere to the right of it. And what it gives me out is X is 3.15 and Y is, and by the way, if you ever see an E with a negative thing, that just means it's a really tiny number. So basically it's 0 right there. And it looks like when X is 3.15. Now they ask when, how long will it take? That's a time. And remember, when you graph this thing, you didn't type in T's, you typed in X's. So X stands for T. So when X is 3.15, the time must be 3.15. So somebody launches something up in the air, comes back down, and after 3.15 seconds, it hits the ground, and the problem is over. And that's essentially all you're going to be doing over and over again. So let's summarize. What do we do real quick? We're just graphing, right? As long as the thing is equal to 0, this would not work, right? You got to move things over to one side. Got to make it look exactly like this in standard form. You go graph this part right here, and whatever the graph calculator says in the context of the problem, you're going to interpret where it crosses the axis, where the zeros are, and write down your answers. If it doesn't cross a pretty number, they might ask you for 2 consecutive integers where it's between. So for this one, for example, your answer is 3.15, and they ask you for consecutive integers where it lies between. It'd be between 3 and 4. So it's just asking you what 2 numbers it's in between when they ask that. And that's all there is for today. So I will let you guys get going on your homework. You got 3.1 due today. You got 3.2 for Monday. So crank those out. And don't forget that 3.2 is due on Monday. You do not have work time on Monday. All right, that's it.